Okay, so the next lesson in this finance unit is on something called compound interest. All right, so on the first one there, we did simple interest, which is when you get paid interest once at the end of the term. Compound interest, it's a little bit different. Basically, over the term, you'll get paid interest in different increments. So maybe after each year, after each month, after each quarter, stuff like that. All right, so with compound interest, basically what's happening is you're getting paid interest on top of your interest. All right, so this to start off with, this is the compound interest formula. So again, the A, just like from the last lesson, A stands for accumulated amount, or we can kind of go with, I would use the word final, so final amount. The P is the principal, so that's the amount that you put in initially. The R is the interest rate. Oops, that's terrible writing, but interest rate. And the N, also shows up there, so how can I do this? Let's do two arrows. The N is what they call the compounding period. Okay, so the compounding period depends on how often the interest is paid. All right, so for example, if you said, if we went with this big old chart over here, if I went annually, n is equal to 1. We have monthly, so you can be compounded monthly, and would be 12. There's also weekly, where n is 52. And what else shows up? Quarterly. So quarterly is 4 times a year, so n would equal 4. Okay, so depending on, after the word compounded, one of these words will show up, and therefore the n will vary, right, depending on how often you compound it. The last variable there, the T, that is the time in years. All right, so yeah, so this formula itself kind of looks a little bit, maybe a little bit complicated, but hopefully through a couple examples here, it'll be clear on how to use it. All right, so let's jump into the first one there, first example. So we're going to calculate the future value of an investment if you invested $5,000 at a rate of 4.3% compounded annually. All right, so after every year for 6 years. Okay, so rather than jumping right into the formula, what I'm going to do is I'm going to pull up a Excel spreadsheet here, and I'm just going to kind of show you manually how you would figure this out, and then just so that you have kind of a visual, right, as to how to get how this actual process works. All right, so we're starting off with 5,000. So next, in the next box here, I'm going to take that 5,000 and multiply it by 0.043. Okay, so this gives me the interest that would get paid after that first year. So this is 4.3% of the 5,000. All right. So if you haven't used a spreadsheet before, don't worry about it. This is just to kind of show you a chart. I'm just creating a chart so you can kind of visually see what's happening. All right. So in this column here, I'm going to add these two together. Okay. So when I add those together, the $5,215 is kind of like the end balance after the first year. Okay. And then in this next box here, I will just transfer over this end balance because this will be our starting amount. Right? And what I can do here is I can just fill these two down. All right. So the next year, 4.3% of 5215 is 224.25. Add those together, we get that total. All right. Now this process repeats itself for 6 years. So our end balance is right here. $6,436.89. And what's happening here is we start off with 5,000. At the end of the year, we get that balance, and then it gets transferred over to the starting balance. Okay. So what you'll notice as well is down this column, the interest is actually increasing. Right. The reason it's increasing is because you're getting paid interest on top of the interest you earned in the previous year. Okay. So that's why these numbers are getting bigger. And the final balance there is $6,436.89. All right. Just as an aside, over here, I'm going to actually punch in. Let's see here. If we were to just do one simple interest, right, just to kind of get a comparison. So 5,000, I'm going to multiply it by 0.043. So again, 5,000. I forgot the one more thing is we're going to multiply this by 6. All right. So this would be if we were to just do the one simple interest calculation. Right. So again, up here in this little bar, I took 5,000 multiplied by the 0.043 and times 6 because it's 6 years. So this is using the simple interest formula. So that total, if I take that and add 5,000, this would be the value of the investment if we were to just use simple interest. Okay, so now you can see that when if I was to compare these two, you can see that the compound interest is more, right? The reason for that again is because you're getting paid interest on top of interest. Okay, so again, I just did this on the Excel spreadsheet here, just so that you kind of see a chart as to what's actually happening. Now, the good thing about the formula is that we don't actually have to fill out this whole chart. We can kind of get to this answer here through a calculation. All right, so that's what I'm going to do now. So I'm just going to switch back over. I'm just going to adjust the screen here. All right, so let's work this out. All right, so the formula again was A equals P bracket 1 plus R over N to the N times T. Okay, so the question is asking to calculate the future value. Okay, so the future value is the A there, so we're going to figure out what A is. If you invested $5,000, so this is the principal. So that's 5,000. 1 plus. Okay, so the rate is 4.3%, but we need to write that as a decimal. And since it's compounded annually, N is equal to 1. Okay, so on the bottom here, sub in 1. And then again, I'm going to write 1 up here, and then multiply it with the number of years, which is 6. Okay, so when we sub in all the values, that's the numbers we get. Okay, so now let's just work this out. So the first thing I'm going to do here is the brackets. Okay, so 1 plus 0.043 divided by 1 is going to be 1.043. And 1 times 6 in the exponent is 6. Okay, so next up, let's pull up the calculator because I cannot do this in my head. Slide that over. All right, so this here I'm going to actually punch it in all in at once. So 5,000 multiplied by 1.043. Where's the exponent? To the power of 6. All right. So this here is 6,436. And I believe it was 89 cents. Let me just get that calculator back up. Yeah, 89 cents. Okay, so there's my answer. And let me just compare it to what we got on that chart because I used the exact same numbers. So there you go, 6,436.89. All right, so that's the same answer there. Okay, so that's just using the formula. Cool. All right, so let's jump to the next one here. This time we want to calculate how much interest was earned on an investment. Okay, so you've invested 8,000 at a rate of 5.5%. So the 8,000 is my principal. This is my rate, 0.055, compounded monthly. Okay, so this is different from the previous example because now we're going to compound it after each month. So that means that n is equal to 12. Okay, and the 5 years, so t equals 5. All right, now the question's asking to calculate how much interest. To get the interest, we actually have to find the final value first. Okay, so we're going to, basically what we're going to do here is we're going to get the final value. And then once we get the final value, we're going to subtract what we actually initially put in, which would be the principal, or the 8,000. All right, so this here is just going to take an extra step at the end, but again, to get the interest, so I'll write that here, interest is going to be the final value minus the principal. Okay, so we know the principal is 8,000. We need to get the final value. All right, so again, let me just quickly write up the formula. All right, and we're going to sub in the values. So when I sub this in, A is going to equal principal of 8,000. 1 plus, okay, R is 0.055, N now is 12, okay, because it's compounded monthly. And up here, I'm going to go N, which is 12, multiplied by 5. Okay, so when you sub in the values, this is what your formula should look like. Okay, so let's work this out here. Okay, so the brackets I'm going to do first. So let me pull that calculator back up. All right, so 0.055 divided by 12 is equal to that. Add 1. All right, so we got this repeating decimal quite a long way, but I'm just going to write the 1.00458. 0.00458. I think there's a 3 after that, and the 3 repeated, so I'm just going to put a bunch of dots there. Now, kind of the important thing as well is we want to save the rounding to the very end. Okay, so I do not want to round this number right here. I want to just store it in the calculator as is. Okay, so leave it in the calculator as is. Oh, and let's do the exponent here. So 12 times 5, that's 60. Okay, so leave the 60 there. Cool. All right, so all right, so let's go to the top of that. Okay, so there's my brackets, or the number inside the brackets, and next up, according to BEDMAS, we're going to multiply or raise it to the power of 60. So to the power of 60 is equal to that number there, and then I'm going to multiply it by 8,000. All right, so as a result, we want dollars and cents. So it's going to be $10,525.63. Okay, so that there is the answer there. Okay, so this one here, oh, actually, you know what? That is the final amount. It's not the actual answer we're looking for. Okay, so again, this is an added step. So to get the actual interest, you want to get the final amount. That's a terrible idea. Let me just how do I erase this? Oh, there we go. Eraser. Yeah, so 525.63 minus the principal, which was 8,000. Okay, so the interest earned when I subtract those is 2,525.63. Okay, so that is my final answer. Okay. All right, so yeah, just a couple things to be aware of is whatever follows after compounded, so monthly, whether it's weekly, monthly, quarterly, that determines the value of the n in the formula. Cool. All right, so these first two examples are using this compound interest formula. Now, the other thing that's covered in this section is something called the rule of 72. Okay, so the rule of 72, I believe you would have seen that last year as well. So this is hopefully some review. It's kind of a simple rule in terms of estimating how long it takes for an investment to double. Okay, so there's two things actually you can use the rule of 72 for. All right, so the first one here is used to estimate how long it takes for an investment to double if you're given the interest rate. And it's a pretty simple formula. The number of years to double, basically all you're doing is taking 72 and dividing it by the interest rate. Okay. Now the other thing you can use the rule of 72 for is to figure out what interest rate you need in order for an investment to double, right, in X number of years. Okay, so the interest rate you need is going to equal 72 again, and again it's being divided by the years to double. All right, so let's go to the first example here, or the next example. We want to calculate how many months to the nearest month it would take for an investment to double, okay, using the rule of 72 if the interest rate is 4.5%. Okay, so real simple. All you're going to do is take 72 and divide it by 4.5, and when we punch that in to the calculator, we get 16. Okay, so 16. And now, thing though is the 16 is the number of years, and the question's asking for the number of months. All right, so if it's 16 years, basically what we're going to do is we want to multiply it by 12 to convert it to months. All right, so 16 times 12 is 192 months. All right. So yeah, rule of 72. Basically, investors use it to kind of quickly estimate how long it takes for how many years it takes, given the interest rate for it to double. Right? All right, and this last one here is just using the other use of the rule of 72. So use the rule of 72 to determine the annual rate of interest compounded annually you would need in order for an investment to double in 12 years. Okay, so 72. Again, we're going to divide it by how many years? So 12 years, and that is, I think I can do that in my head. 6. All right. So 6% is what you need, all right, in order for an investment to double in 12 years. All right. Okay, cool. So that is compound interest.